Okay, let's get into this. Think about that moment we first saw a photograph of Earth from space. You
Oh,
know,
yeah, the blue marble shot. Huge perspective shift.
exactly. That sudden, wow, that's us feeling. Well, today, we're diving into something that could spark maybe an even bigger change in how you see everything.
We're talking about finding life beyond Earth, right?
The very real and, well, increasingly possible idea of finding life out there.
And it's fascinating because this isn't just, science fiction anymore. It's happening now.
Right, like this recent news about K2-18b.
Yeah, the detection of that gas, dimethyl sulfide, I think. A gas that here on Earth is basically made by simple marine life,
Yeah,
plankton and stuff.
so finding it there. Well, that brings us really close, potentially, to answering that huge question. Are we alone?
It feels closer than ever. And Prof. Nkrumah, who's leading this research,
Yeah, what did he say?
he put it really well, saying we could be right on the verge of answering that fundamental question.
Wow. So, okay, that's our mission for this deep dive then. To really unpack what a discovery like that would actually mean based on, what the science is telling us right now.
And, it's interesting to think about the history here. Humans have wondered about this for ages.
Oh, absolutely. Go back to what, the early 20th century, people thinking they saw canals on Mars?
Exactly. Percival Lowell and all that.
Yep.
And that really fueled a whole wave of science fiction, didn't it?
Totally. Flying saucers, the classic little green men,
Yeah.
it just like exploded in the public mind.
It really did.
Yeah.
Amazing how that took hold.
And it's funny how the tone shifted later, like during the Cold War.
Aliens suddenly became menacing threats.
Yeah, maybe reflecting our own fears back then, projecting them outwards.
Could be. But the actual scientific search, well, that's really changed focus in the last few decades.
It's moved beyond just our solar system, hasn't it?
Oh, completely. The big turning point was 1992, the discovery of the first planet orbiting another star like our sun, an exoplanet.
Before that, it was mostly theory, right? Other solar systems.
Pretty much now. We've actually confirmed, nearly 6,000 exoplanets.
6,000. That's incredible. And a lot of the search focuses on this Goldilocks zone idea.
That's the one, the habitable zone.
Yeah.
Basically the area around a star where it's not too hot, not too cold,
Just right.
just right for liquid water to potentially exist on a planet's surface.
Because water, well, liquid water seems essential for life as we know it.
That's our current understanding, yeah. And Prof. Madhusudan, he thinks there could be maybe thousands of planets like that just in our own galaxy.
Thousands. Wow. Okay, that really changes the odds, doesn't it?
It does. And the technology we're building to actually study these places, it's mind-blowing.
Like looking at their atmospheres from light years away.
Exactly. Developing these incredibly sensitive instruments to analyze the chemical makeup of alien air. We're hunting for biosignatures.
Biosignatures, so molecules that suggest life.
Molecules that, on Earth anyway, are made by living things, like that gas on K2-18b.
And that K2-18b detection, that was the James Webb Space Telescope, the JWST.
That's right. Huge deal when it launched. Everyone was so excited about its potential for this kind of work.
And it's delivering. But it has limitations, too, you mentioned.
Yeah, I mean, it's incredibly powerful, but think of it like, trying to see a tiny little firefly buzzing right next to a giant, blinding searchlight.
The star's glare overwhelms the planet's faint light, especially for small planets close in.
Exactly. JWST struggles with that specific scenario.
Okay, so that's where the next generation of telescopes comes in. I think I read about some new ones being planned.
Definitely. NASA's got the Habitable Worlds Observatory, HWO, planned for the 2030s.
HWO, what's special about that one?
It's going to use this really sophisticated shield, like a giant parasol in space, to block the starlight directly.
So it can actually see Earth-like planets and analyze their air.
That's the goal. Direct imaging and atmospheric analysis of potentially habitable worlds.
Incredible. And isn't there a massive ground-based one coming online soon, too? Down in Chile.
Oh, yeah, the ELT, the extremely large telescope from the European Southern Observatory.
Extremely large. Sounds about right.
It is. It's got this colossal main mirror, 39 meters across.
Yeah.
Biggest ever for an optical telescope. It'll give us incredibly detailed views of exoplanet atmospheres from the ground.
So, okay, we've got JWST, we've got JWO and ELT coming. If Prof. Madhusudan gets more data, say, confirming that gas on K2-18b, does that mean, boom, we found alien life, case closed?
Well, not quite so fast. Even he would say that. Strong evidence, yes. But it would be the start of a massive scientific debate.
Oh, Right, you have to rule out everything else first.
Absolutely. Scientists would tear it apart, looking for any possible non-biological way that gas could be produced. Weird geology, unusual atmospheric chemistry, anything but life.
That makes sense. Exhaust all other options. I remember reading Prof. Catherine Hayman's talking about this, about how acceptance might happen gradually.
Yeah, she had a good take on it.
Yeah.
It's like building a case, piece by piece. If we start finding similar biosignatures, not just on K218b, but on other planets,
Yeah.
maybe detected by different telescopes.
Using different methods.
Exactly. If the evidence keeps piling up across multiple systems, then the scientific community will slowly, gradually shift towards accepting that, yeah, the probability of life being out there is becoming really high.
It reminds me of that analogy about the World Wide Web.
How so?
Well, it wasn't like one day the internet just appeared. It was lots of small breakthroughs, right? Little steps, protocols, browsers that eventually added up to this huge world-changing thing.
That's a really good analogy, actually.
Yeah.
Maybe realizing we're not alone won't be a single eureka moment, but more like a slow dawning, a growing realization as the evidence becomes undeniable.
And while we're looking light years away, we shouldn't forget about searching closer to home, right? In our own solar system.
Oh, definitely not. In some ways, finding something here could be even more profound, more immediate. Well, imagine actually getting samples, sending a probe, scooping up some Martian soil or icy moon water, and finding actual microbes, little off-world bugs.
Or bringing samples back to Earth labs for analysis.
Exactly. That kind of direct, hands-on proof. That would be incredibly powerful. Hard to argue with.
And there are missions working towards that, aren't there? Like Europe's ExoMars rover.
Yep, ExoMars. Planned for 2028, I believe. It's designed specifically to drill down below the Martian surface.
Below the radiation and harsh conditions.
Right. Looking for signs of life, past or maybe even present, preserved underground. Probably fossilized evidence, given Mars today.
And China's got a big mission, too. Tianwen 3.
Also aiming for around 2028. A very ambitious sample return mission, collect Mars rocks and soil, bring them back here by maybe 2031.
Wow. And then there are the missions heading out to Jupiter's icy moons, Europa, Ganymede.
And Saturn's moon Enceladus, too. NASA and ESA both have plans, probing those subsurface oceans we think are hidden beneath the ice.
Oceans of liquid water, potentially warmed from below.
Exactly. Now, these current missions, they're mostly about checking things out first. Mapping, understanding the chemistry, the geology.
Well, laying the groundwork, basically.
Precisely. They're not full-on life detectors yet, but they're essential first steps before we send missions specifically designed to hunt for life in those alien seas. We need to know what we're diving into, so to speak.
It makes sense. And speaking of moons, what about Dragonfly? Going to Titan.
Ah, Titan. Yeah, NASA's Dragonfly, launching around 2028, arriving mid-2030s. It's basically a nuclear-powered drone designed to fly around in Titan's atmosphere.
Titan sounds so weirdly fascinating. That thick orange haze, lakes of methane.
It's an incredibly alien place, carbon-rich chemistry everywhere. Almost reminds you of that Beatles line, Marmalade Skies.
Huh. And that carbon chemistry plus water ice, maybe liquid water underneath.
Yeah.
That's promising, right?
Very. Those organic molecules are the building blocks of life as we know it.
I remember reading Prof. Doherty sounds pretty optimistic about these icy moons in general.
She really is. Her argument is quite strong. You've got three key things. One, a heat source, probably tidal forces from the giant planets they orbit.
Keeping things warm inside.
Two, strong evidence for liquid water, those big subsurface oceans. And three, plenty of organic chemicals, the raw materials.
Heat, water, organics, the recipe.
For her, yeah. Put those three together and the chances of life starting seem, well, significantly higher.
So let's say we find it, whether it's on K218b or Mars or Europa. What kind of life are we talking about? Simple stuff. Complex.
That's the billion-dollar question, isn't it?
Yeah.
Raf Madhusudan, looking at K218b, suggests if life's there, it's probably simple, microbial, maybe common across the galaxy.
Just little single-celled things.
Potentially. But he stresses, and this is important, the jump from simple life to complex, multicellular life, and then to intelligent life. That's a whole different ballgame. We just don't know how often that happens or if it's incredibly rare.
The conditions needed, the evolutionary path. It's a huge unknown.
A profound unknown, as he put it.
Dr. Robert Massey had an interesting point about what finding even simple life would do to our sort of human ego.
Yeah, his perspective is that it continues this long trend, this diminution of humanity's specialness, I think he called it.
Meaning?
Well, astronomy keeps showing us we're not the center of the universe, right?
Yeah.
Copernicus, Galileo. Finding life elsewhere, even just microbes, would be another step. It would show we're not biologically unique either.
Just another branch on a potentially much larger cosmic tree of life.
Exactly. It's humbling, really.
It is. But Prof. Doherty saw it a bit differently, didn't she? More positively.
She did. She thinks finding life elsewhere, even simple life, would actually enrich our understanding of ourselves
How so?
by giving us another example of life to compare ourselves to. It would tell us so much about how life starts, how it evolves. It would connect us, she feels, to a bigger cosmic story. Make us feel, well, bigger, not smaller. Part of something vast.
That's a nice way to put it. A sense of connection rather than demotion.
Yeah. And Prof. Mathusatan, he painted this really hopeful picture, too.
About the societal impact.
Mm-hmm. He talked about looking up at a living sky, knowing there's life out there among the stars.
A living sky.
And he hopes that realization, that fundamental shift in perspective, could actually help dissolve some of the barriers we put up between ourselves here on Earth. You know, national borders, languages.
Seeing ourselves as just earthlings, part of a cosmic neighborhood.
Maybe foster a sense of unity, recognizing we're all in this together on this one planet in a potentially living universe. It's a powerful thought.
It really is. Okay, so wrapping this up. It feels like we're genuinely closer than ever, doesn't it? The technology's racing ahead, the missions are out there or getting ready to go.
Yeah, exploring exoplanets light years away and poking around in our own cosmic backyard, the chances seem higher than they've ever been.
And whether we find simple microbes or, well, who knows what, the discovery itself would just be immense, game-changing.
Absolutely transformative for how we see the universe and, yeah, how we see ourselves within it.
Which brings us to a final thought, maybe something for everyone listening to chew on. If tomorrow definitive proof of life, even just microbes, was announced, how would that really change your view of your own place in the cosmos, your connection to everything else on this planet?
Yeah, what would shift for you, and what's the very next thing you'd want to know? What would be the first question you'd ask the scientists?